Hello everyone. Now we will discuss on the topic solid waste and hazardous waste management part 1. Already we have discussed on the management and treatment of different type of waste streams like air, water, and the next part is with solid waste and the hazardous waste, and the contents are classification of solid waste management system, routes of solid waste management, landfilling, hazardous wastes and their management, and waste plastics management. Now, we will see the classification of solid waste. So, the name itself indicates that the waste will be in solid phase or solid state. So, we can classify the solid waste based on some criteria, like say based on source. It can come from domestic or municipal sources, it can come from industrial sources, or may it come from the forest. Okay. So, industrial solid waste, agricultural wastes, and domestic and municipal solid waste, that can be the classification, that agricultural and forest waste are under the same category. And based on biodegradability, this can be biodegradable and non biodegradable, and based on combustibility may be combustible and non combustible, and based on compostability, that is compostable and non compostable, and based on usability, that can be organics, recyclable and inert. So, these are the different types of classification of solid waste. Now, we will see the characteristics of municipal solid waste. So, municipal solid waste, if we see, around 50% contains biodegradable material and around 20% contains recyclable materials and around 22% inert material and 8% is others. Now, we will see that biodegradables may be the foodstuffs, landscape tree trimmings, and recyclables may be paper, tablets, plastics, glass, metals, etc., and inerts may be stones and silt and other inorganic material, that is construction debris, etc. So, these are the different components which is available in the municipal solid waste and their relative contributions on the overall volume of the MSW. Here we will see the source of MSW from different parts of the country and their composition and some characteristics, like say if we see metros, metro cities and other cities, and East India, North India, South India, West India and overall urban India, if we classify these and if we see the municipal solid waste. So, their concentration of different types of materials will be different and their properties will also be, particularly the heating value and moisture content will also be different. And this table shows us some example case study that is based on 2012 study. So, these are the total production in ton per day and these are the compostable present in it. So, it is evident that around 50% plus minus some compostable material is available in the MSW produced in the different part of the country, and recyclable materials also say 16 to 21.44% is mentioned here. So, around 20% we can say or 22% we can say that recyclable is there maximum. So, inert is also present there, you see 32.82 and somewhere it is 29 like this. So, that way inert material is also present and moisture content is also mentioned and calorific value we see. So, calorific value is not very high, but it can be recovered. Okay. So, this is the characteristics of MSW available in the country. Now, although the calorific value is less we see here, but if you can segregate the different components, because you have seen that here inert is around 20 somewhere 32% somewhere. So, if we can eliminate this part, so this your calorific value will be increased. So, segregation of MSW if you can do, then the particular fractions we can get that can have very high heating value and less moisture content, whereas some other part may have the reverse trend, that is less heating value or high moisture content like this. So, different types of components if we segregate, that paper, cardboard bags, and then wood, carrots, boxes and scraps, and then bush, branches, leaves, grass, garbage, green stuff, greens, rags, cotton and linen. Some examples are given. So, we see here the moisture content is varying widely, 5% to 75% here, and heating value is also varying widely, that is 4.23 megajoule per kg to maximum, it is mentioned here 18.20 megajoule per kg. So, 18.20 megajoule per kg is a good amount of heat content this type of materials is having. So, this can be used for the energy recovery, but where these materials, although the heating content is less, but its moisture content is high. So, this can also be treated biologically for the recovery of the energy or the production of biogas, and overall value addition can be taken place through the treatment. Similar to MSW, the industrial solid waste will also contain different types of materials, but it will be having some specific characteristics, some depending upon the type of the industry, a particular type of pollutants may be available in the solid waste, and that has to be removed first before further treatment using the conventional solid waste processes, management processes. Now, we will see the characteristics of the agricultural waste, that is lignocellulosic biomass or lignocellulosic agricultural residues. So, here some examples are given, say grass, corn stover, bagasse and wood chips, and here we see cellulose, hemicellulose, lignin and others component present in this type of materials is given in certain range. So, certainly we see that cellulose is present in the highest extent, followed by this hemicellulose and lignin, and if we see that lignin, hemicellulose and cellulose have different structures, because all those compounds are having different chemical formula and their structure are different, and some are having some crystal structure like say cellulose, and hemicellulose is having less organized crystals, and this is the structure of this. So, this information will help us how to use these feedstocks or these wastes as a feedstock for the production of energy. Now, we will discuss the solid waste management systems. So, now we have seen that different types of solid waste are generated, including MSW, industrial waste, agricultural waste, etc. Now, our objective will be how to manage these wastes, particularly the management of MSW is a very big challenge. So, it requires technological application as well as the management concepts or management application. So, if we consider the management of solid waste, so first will be the source of generation of the waste. So, we should try our level best to reduce less waste. So, that will be the first principle or first philosophy for the solid waste management. Then when it is generated, then that has to be handled and collected properly. So, waste handling, separation, storage and processing at the source. Each and every individual houses we produce solid waste. So, we should take care that we will producing less solid waste, and once the solid waste which is generated, that has to be managed properly. It has to be handled properly, so that it will not create environmental hazards in the surroundings, and that after this storage and processing at the source level at each individual houses, we can segregate the solid waste into different fractions, and municipality can implement a methodology to collect different fractions for their proper management. And then collection system is there, that collection, there are different techniques available for the collection of MSW from each and individual households, and after this collection it has to be transferred and transport to the processing section, or where the segregation and processing and transformation of solid waste are taking place. So, after that the segregation and processing, that means as you have mentioned there are recyclables, there are organic compounds and there are inerts. So, after this recyclable, after this segregations we can select particular routes for the processing of different fractions for further utilization, value recovery as well as to reduce the volume of the waste. So, that reduced volume will further be disposed. Okay, so, this is the scheme for the waste management, particularly the MSW. And so, now we will discuss all these functional elements now. So, waste generation and collection. So, waste can be generated in a low building or high rise building, low rise and high rise buildings. So, for these two different types of buildings, different types of methods have been applied and implemented for the collection of the solid waste, like say for high rise building, curb, alley, set out setback, set out backyard carry. So, all those things are there, and high rise building screw can collect waste taken to service area by tenants and tenants putting the waste in chute. So, these are some methods which are used in different part of the world for the collection of the solid waste. And if we think about the collection systems, so basically major two types of collection systems are used. One is your hall container systems and another is your stationary container system. So, stationary container systems are basically used for contents to be transferred to the collection vehicles at the site of storage. So, this is the site of storage, waste are collected here. So, transporter municipal vehicle will come. So, here this waste will be transferred. So, that is your stationary container system, but in case of hall container system, this is used for the contents to be directly transferred to processing plant, transfer station or disposal site for emptying before being returned to the storage site. So, this container directly it is taken to the disposal site or processing site with the carrier, and then after unloading it is again returned to this place. So, that is called hall container system. So, these are the different types of systems which are used for the collection of the solid waste, municipal solid waste. So, these are different types of systems used for the collection of municipal solid waste in different parts of the country and in the world. Now, we will see the segregation, transportation, transformation, segregation, transformation and transportation. So, segregation may be done at source or at transportation site. So, when it is transformation site, so when we are going to transform it, that means we are going to extract energy or some other valuable from it. So, at that site, or it can be sorted at the site where it is being generated as well. Okay. So, transformation means the value addition or extraction of energy and other products and reduce the volume of the residue basically, and this transformation helps to achieve efficient storage, handling and transport, reduced disposal cost, stabilized waste, destroyed toxic element, that is chemical and biological entities, those are being destroyed, electrical energy generation and reuse. So, these are the advantage of the transformation, and transportation needed and the illegal dumps we want to prevent, and then disposal site too far and small capacity collection truck and low density area and more waste to large distance. So, we have a certain area where the waste will be collected and disposed, and then at that time this will be far away from the main city. So, that is the reason why this transportation is required, and different types of transportation systems can be used like motor vehicle, railways, hydraulic systems, pneumatic conveying systems and compressed air or vacuum. So, these are depending upon the situation. In our country mostly motor vehicles are used. Now, we will see the disposal options. So, disposal of waste, the residual part of the solid waste after transformation which is remaining, that has to be disposed, and there are many methods through which the disposal can take place: open dumping, landfilling, disposal of residual solid waste in surface soils of the earth and barging into sea and feeding to hogs. So, these are some generally used disposal methods. We will discuss the landfilling and others also. So, open dumping we have seen it is it is practiced in most of the towns and cities in our country, and landfilling is also implemented in metro cities and some other cities in the country. And barging into sea, that was a good option once, but nowadays it is not encouraged. Now, we will see the routes of solid waste management. So, those are the disposal option we have seen. We have seen that solid waste or MSW has to be collected, it has to be segregated, then transformation, and then residual will be disposed of. So, these are the basic steps. Now, we have also seen that MSW or solid waste may be of different types, like say someone is recyclable, some part is non recyclable, some part will be having organic content, some part will not be containing any organic, or some part it will be containing more moisture, some part will containing less moisture. So, likewise we will see different type of wastes, how we can manage it. So, segregated at source, the first step is to segregate. Second is to identify different fractions like say recyclable waste and then organic fraction, inert debris and hazardous waste. So, if it is a recyclable waste, that may be non combustible or may be combustibles. If it is non combustible like say glass, metals, etc. So, those will be used in the industries through the recycling process, and if it is a combustible, then those can be used for the energy production, and like say packaging material, paper, plastics, these are some examples. So, those can be used for the fuel pellets productions, and the plastics can also be recycled to produce different types of products. So, this is one way of the management of the recyclable wastes, and then some other type of materials which is having organic fractions, high organic fractions like say biological treatment can be suitable for that, and composting, vermicomposting, biogas and landfill gas production can take place from this type of solid waste. Already we have discussed about the composting, vermicompostings and biogas production, and landfill gas is produced in the similar way. Similar types of reactions are also responsible for the production of landfill gas like anaerobic digestion. So, we will discuss this one, and for inert debris, those are not having any carbon content and those are not suitable for energy productions or valuable extractions. So, those will be used or those can be used for the road constructions or paver productions or paving of roads. And if the material is of hazardous in nature, then that may be of from different sources, maybe from hospital waste or maybe from other sources. In the solid waste which comes from hospital waste, all are not having the hazardous characteristics, some of those are having hazardous characteristics. So, this is classified as a special category waste, and we will discuss it in detail for its management. And one example is given here, that incineration, that is one of the method which can be used for this type of for managing this type of waste, but we will be having more discussion on this in detail. And some other type of wastes may be like say e-waste or any other type of waste. So, those are maybe a special type of waste. So, for those waste materials some special methods are recommended and those are followed. Okay. So, accordingly the planned according to the specific requirement. So, management can be planned according to the specific requirement, and whatever may be the residual part generated from different methods, that can be ultimately disposed through landfilling. So, landfilling is the mostly used for disposal of residual wastes. So, this is the routes or schemes for the solid waste management. Now, we have come to know that some part of the MSW which is having high carbon and hydrogen content and heating value, those can be converted to energy. So, that conversion can take place basically through thermochemical conversion, biological conversion, chemical conversions and physical conversion. And physical conversion like say mechanical extractions, briquetting of biomass and distillation. So, these are the prerequisite for some other type of conversions, and thermochemical conversions like combustion, gasification, pyrolysis, liquefaction, which are very important, and those processes give us different products like FT oil to gasification, bio oil from pyrolysis, heavy oil from liquefaction. And biological conversions, anaerobic digestion, fermentations and enzymatic reactions. So, that can give say methane or biogas from fermentation, ethanol, and from enzymes ethanol, amino acids, etc. And chemical conversion like hydrolysis, solvent extractions and transesterification methods are used. So, here cellulose, hemicellulose and lignin, through this we can get lignocellulosic materials to cellulose, hemicellulose and lignin, and then solvent extraction give us primary and secondary metabolites. So, these are the different methods which are used for the transformation of the solid waste for energy production. Now, we will see what is landfill and we will discuss on it. Now, we will discuss on landfill. So, we have seen that landfill is one of the important method for the final disposal of the residual. Okay. So, that it primary means of MSW disposal we can say it is the primary means of MSW disposal, and disposal of residual solids in the surface soils of the earth. How it is done? We will see in the surface soil of the earth, and then depending upon the nature of the solid waste, the landfills may be of different types or may be classified into different category, like say secure landfills, class 1 landfills, that is designed to handle hazardous waste, and then monomials or class 2 landfills designed to handle particular types of waste such as incinerator ash and sewage sludge that are relatively uniform in characteristics and require special handling, and sanitary landfills, that is class 3 landfills, that basically is suitable for non hazardous materials and the residual part of municipal solid waste are processed through this route, and engineered facilities are designed to handle MSW. So, these are the different types of landfilling sites which are used for the handling of the residue of different types of solid waste. If we consider a landfilling site, so we will see that there are some active filling area when daily the residual part of the MSW is coming and dumping here, and then this is lowland, and then there will be some soil cover for everyday filling, there will be some soil cover, and when it will be complete, then the complete it will be covered with sand with certain thickness, and then this will be filled, and next there will be some area for future fill area, and certainly there are some area where already the landfill has been completed. So, completed fill and then active filling area and future area, those are very essential area requirement for the landfilling. We also put some soil every day. So, stockpiled for cover material is also needed, we need to store somewhere. So, these are the different area requirement for the operations of the landfilling. Apart from this, we have discussed that this landfilling will be creating some leachates, and there will be some landfill gas production. So, there will be some leachate treatment facility, gas flaring facility and surface water collection facility. So, these are very essential part of a landfilling area, and we also need to manage the environmental qualities. So, environmental monitoring facilities are required, and temporary holding area is also required. It also need one office space and road for access and weighing scale, inspection and screening facility and equipment or workshop. So, these are the different parts of the landfill area, or we can say this is the typical layout of a landfill. And if we see the landfill process, so here landfill process, you see here the residual material is collected and then it is put in the lowland and it will be covered with the soil. Okay. As shown here, this is original ground level. So, this is compacted waste cell, waste material is compacted here. So, you see some rollers are running. So, it is being compacted and then daily earth cover. So, 6-inch cover is there. After 1 day compaction, some earth is given, okay, on the solid waste. Then solid waste residue, some earthy material is given and then it is covered and then it is pressed and compressed, and then daily we will having the same operation on the daily basis, we will be having the same type of filling on daily basis, and when the complete fill will take place, then ultimately final earth cover of 2 feet has to be provided at the top. So, this is the fill process, and this slide shows us some live photographs of landfill sites at Gazipur, Delhi, and this shows us this is your active sites and this is your field site where the landfilling has been done and that area is restored. Okay. So, landfill restoration, that is covering a landfill once it has reached its maximum capacity and transforming it into usable land. So, this is the example of the restoration of the landfill, and different types of reactions which can take place in the landfills, that those are similar to anaerobic digestion reactions like say aerobic phase and acidic phase, and then methanogenesis and methanogenesis phase, unsteady and steady. So, in this case at the top part there is the possibility of oxygen. So, aerobic reaction can also take place, and as we go inside, when the depth increases, then acidic phase reacts, then after acidic phase methanogenesis phase reactions takes place. This is unsteady and then steady state. So, similar reactions which take place in anaerobic digestion, and this is a modern landfill. So, here we see this is your lining is done. So, for leachate collection, and landfill liner is shown here, and this leachate treatment system is there, and trash and clay cap is provided at the top, clay cap is provided, and inside the trash the material is put here, and methane gas recovery system is also there. So, where biogas is produced and water is going there. So, but this is not be installed or implemented near a groundwater well. So, groundwater well should be certain distance away from the landfill site. Now, one example we will see, a country discards 146.6 million tons of MSW per year. If the population is roughly 260 million, what will be the landfill volume of reuse for 1 lakh people? Assume a landfill density of 600 kg per meter cube and a single 3 meter lift. Also assume that 20% of the cell volume is soil used for cover. So, now we will calculate the volume of the MSW. So, how can we calculate? We have total 146.6 million tons of MSW per year. So, this into 10 to the 3 kg per year. So, conversion of ton to kg, and then we have this 1 lakhs people, okay, and for 1 lakhs people we have to calculate. So, this waste is generated from 260 million people. So, per unit people, so this divided by 260 into 10 to the 6, okay, into 600, because 600 is the density of the landfill. So, this is we are multiplying this term and dividing it this term, then multiplying this total people. So, this will be the total mass of the waste generation, then divided by this density. So, it is giving us the volume. So, this will be the total volume, but 20% of the cell volume is soil. So, that the actual volume will be more than this. So, that will be divided by 0.8, so that is equal to 117468 meter cube. Now, the area of lift at 3 meter cell depth, the cell depth is 3 meter, it is given. So, 3 into A area, that is equal to volume. So, A equal to volume by 3, so that is equal to 39,155 meter square. So, this value we are getting, that is based on the mass balance. So, material mass balance, but we also discussed that it requires some other sites as well. This is the active filling site, but some other auxiliary areas are required. So, actual size will be much more than this one. Now, we will see the hazardous waste and their management. So, hazardous wastes are materials that are known or tested to exhibit one or more of the hazardous traits, that is corrosivity, toxicity, flammability, ignitability, reactivity, etc. So, these are the different traits. So, these wastes have either one of these or all of these or any two or any combination of these properties. Okay. So, these may be in liquid, gas or solid state, and different techniques used for solid waste management may be implemented for hazardous waste management also. So, whatever methods we have discussed, those can be implemented for this also, but there is one condition, that prior using this process it has to be decontaminated or the hazardous component has to be eliminated from it. So, hazardous waste must undergo different treatments in order to remove the hazardous characteristics before further processing. Otherwise, this must be stabilized and disposed in more regular or more regulated manner. For example, a barrier has to be installed along the foundation of the landfill to contain the hazardous substances that may remain in the disposed waste. Most flammable materials can be recycled into industrial fuel, and some materials with hazardous constituents can be recycled, such as lead acid batteries. So, these are some examples of the removal of the specific characteristics from the overall waste, so that the remaining part can be used following the same MSW management processes. Now, we will see the waste plastics. We have seen that municipal solid waste contains good amount of waste plastics. Okay, that waste plastics can be managed by applying certain rules. The waste plastic management, certainly we can go for landfilling, but we can transform this part of the municipal solid waste into valuables. Okay. And the philosophy for the plastic waste management is based on the 5 R's. So, those 5 R's are basically refuse, reduce, reuse, repurpose and recycle. Refuse means we should put our best effort not to use plastics. So, whenever applicable we should avoid the use of plastics. For example, so when we go to shopping malls or any grocery shop, if we take a jute bag or any other bag, so we can ask the shopkeeper not to give the plastics to us. So, if we all of us implement this practice, certainly the waste plastics will not be able to come into the waste stream, the volume of waste stream will be reduced. So, that is refuse, and reduce, that is reducing consumption is all about the virtue of conservation and the notion of doing more with less. So, this is another similar type of philosophy. Somewhere it is inevitable, we need to use the plastic materials, but we can optimize it, we can reduce it. And then reuse, reuse the waste which is being generated, that can be reused. Okay. That way it does not go to the rubbish and end up in the landfill. Some small additions or changes make the trash into treasure. And recover, repurpose, this is the recovery of waste without any pre-processing. For example, waste oils that cannot be refined for reuse in vehicles can be burned for energy recovery. So, recovering the energy from waste oil reduces our dependence on coal and imported oils. So, similar way the plastics can be also converted to other form that can be used for other application. And then recycling involves some form of reprocessing of waste materials to produce another product, for example, recycling plastic bottles to make buckets. Now, various recycling techniques which are applicable for the management of waste plastics, if we consider, then we are having say primary method, then secondary, then tertiary, then quaternary. So, this quaternary basically incineration, that is banned in the country, that is not practiced, and not allowed by CPCB. And this secondary and tertiary are mostly favorable, primary and secondary separations is bit difficult in some time. Okay. And we secondary and tertiary are a main important method. In the secondary, that is mechanical transformations of the plastics, that is pelletizing, extrusion, injection molding, drawing and shredding. So, these are the different mechanisms or processes which are used, like say waste plastic to paver block or tiles production, one example of this mechanical conversion. And chemical or thermolysis are the part of the tertiary treatment, like say chemical recovery and energy recovery. So, chemical recovery, that can be heterogeneous or homogeneous phase. If it is heterogeneous, by using some catalyst, that will be cracking, gasification, and then this cracking can give us chemical catalytic products, and then hydrocracking, catalytic cracking, hydrocracking, and some other chemical reactions can take place through this. And homogeneous, that can be chemolysis, that is methanolysis, glycolysis, alcoholysis and hydrolysis. Okay. So, these are the different methods, and for thermolysis, basically thermal application of heat for the breakdown of the compound. So, that is pyrolysis, gasifications and hydrogenation. So, these are the different reactions or paths which can be used for the management of waste plastics. So, in this class we have discussed different methods for the management of solid waste, including hazardous waste and plastic waste, and we will be discussing some transformation methods in consecutive classes. After this, in this class, thank you very much for your patience.